Okay, hello everyone. So, can you see my cam?
Yes, yes, we can.
Yeah, we can see you.
Okay, everyone. So, as you know, this is gonna be an intro to AI workshop. We're gonna introduce you to AI. We're gonna introduce a few terms, and this meeting, يعني, very few people are here. So let's make it interactive. I want to hear your voices. Unmute yourselves every time you have a question. No need to ask it on the chat. Okay. So let's start and let's dive into the artificial intelligence world. Today we're gonna be introducing Beirut AI, our community. We're gonna do an intro to artificial intelligence, take a 5 minute break, and then do a hands-on workshop together. So we're gonna actually code an AI. But first of all, meet your instructor. I'm Hadi Abu Daya, machine learning specialist at Mobile Arts, and you can find my LinkedIn URL down below. I'm very excited to give you this workshop, and let's first begin with by talking about Beirut AI. So we are the biggest applied AI community in Lebanon. We do a lot of hackathons, workshops, courses, and we are happy if you join our community and become a member. So you can go to our website, beirutai.org, and you can see everything there. Beirut AI is part of City AI, which is present in more than 60 countries. And what something that we're very proud about is that we are one of the most active communities in all around the world. So you can find our social media below, and you can also become a member. So let's start. What is AI? Is this AI? It's يعني, the like the movies that you watch. It's like a robot that's gonna take over the world. Can someone tell me, is that AI? Please unmute yourselves.
Yes and no.
Okay, so you're correct. It's a no. At the moment, AI can't do this stuff. At the moment, AI يعني, is used to do tasks that we train it to do, and as we see in these pictures, and it usually makes silly mistakes, and it doesn't have the full understanding. For example, here it thinks Batman is in the image here, but actually it's the reflections in the mirror. So يعني, at the moment this is AI. So let's define artificial intelligence. AI is what allows machines to process large amounts of data, recognize hidden patterns in those data, perform human-like tasks, learn from experience, and adjust to unseen inputs. We have three types of AI. We have narrow AI, general AI, and super AI. So narrow AI is an AI that is highly focused on one task, and it knows to do one thing. It doesn't know anything else, but and this one thing it can do better than most humans. General AI is an evolution, let's say, for narrow AI. It can do multiple stuff better than humans, and it becomes very powerful. And super AI is just an AI that doesn't need humans. It auto evolves, and it can do whatever it wants. So, where do you think we are in this spectrum? Are we in narrow AI, or have we reached super AI, or are we in the middle in general AI?
That's
What do you
narrow.
think? Let me hear. I couldn't hear you.
That's narrow AI. So
Okay, so I think you said general AI. I couldn't hear you well. So at the moment, yeah, some people say that ChatGPT is general AI, but actually what it does is it predicts the next word, let's say. So it does a prediction tasks for only one thing. Uh, it's very powerful, but it's still considered narrow AI. So we are still in the narrow AI phase, and to define artificial intelligence, artificial intelligence needs three pillars. So it needs the algorithms, the data to train the algorithms. So the algorithms should learn from large amounts of data, and this learning process should be hosted on hardware. So we need these three pillars to make AI happen. And some applications of AI nowadays are in risk detection and fraud for insurance companies, healthcare, targeted advertising, internet search, speech recognition, and advanced image recognition. So please, can you share your ideas and give me some applications of AI nowadays? Where do we use AI? Please unmute yourselves and tell me.
Everything has to be content creation, whether text or visuals.
Exactly. So there are many models now that a text output or an image output or even video. So that's now possible. Exactly. Any other ideas? Okay, so let's do this test for you. Okay, we have 8 images of people, and uh, as you previously mentioned, we can do content creation, so we can generate images. Some of these faces are generated, so generated by AI, and some are real. So can you please tell me which faces are generated by AI and which ones of them are real?
I think they're
What
all
is
generated by AI.
exactly? They're all generated by AI, and you can generate your own face by going to not this website. Okay, so you can generate your own face by going to this website. Let me show you. So can you? What am I sharing? Can you tell me? Oh, okay.
a blonde.
Exactly. So when you refresh this website, it just generates a new face. So and this website generates a face that nobody has ever seen before and nobody will ever see. It just generated it right now, and it's gone forever when you refresh it. So it's quite interesting, and this is what we call generative AI. So generative AI is when we do, يعني, for example, a text prompt. So we give an input to the AI, and it generates an image in return. So this is generative AI, and to the left we can see the deep Tom Cruise. So have you seen deep fakes, or have you heard of
Yeah.
deep fakes before? Deepfakes are when we clone somebody, for example. So we can clone their facial expressions and their voice, and we can make them say whatever we want. And here a person created a TikTok account for Tom Cruise, a deepfake Tom Cruise. And let's see together some of AI's use cases nowadays. So we all know the self-driving cars, the Tesla self-driving cars mainly, and they use computer vision and deep learning to, by scanning the road with cameras, they detect where the car can drive, they detect obstacles, and the car now learns how to weave through the obstacles, not hit anything, and drive itself. We have also style transfer. So we give it this image, this A image, and we can tell it to draw this same image in any style that we want. So here we give it other images, and our previous image is then drawn in the styling of the second image. Facebook has a feature that helps the blind see, so it gives them context of what's in the image. We all know the virtual assistants, Alexa, Siri, and others, and Google Assistant. So they understand our language. We ask them a question. They translate this voice into text, then analyze the text, and then they reply back with the text. The text is then made text to speech, so we can hear it, and then they answer us. So we can have a conversation with them. Facebook has also this feature from a long time ago. When you take a picture with your friend, it automatically recognizes the face of your friend and tags them in the photo. So this is face identification or person identification. It uses computer vision to detect the face, and then it scans it and knows which face it is. Google search. So we have never gone to the next page in Google search. Whenever we search for something, we always find it in the first two or three people, two or three links. So this is the power of Google search. It recognizes our question and gives us the most relevant links first. Same thing for tweets, same thing for Instagram, TikTok, Facebook, all of those. They recognize our preference and then feed us the content for our liking. So the first posts are always the posts that we like the most. This company, GNC Healthcare, is a company that uses AI to predict the treatment results of their patients. So they can give targeted treatment to each and every patient. And another company called Atomwise uses AI to build enzymes. So enzymes are built from proteins, and each protein has a certain architecture for it, and the architecture is what the architecture of the protein tells it what it does. So here this company uses AI to help build the actual architecture of the proteins and make it a usable enzyme. But the question is, why now? So AI has been a word that's used since the 1950s with Alan Turing. But why did the boom occur now? Does anybody have any idea?
It's much more accessible, and we were able to train it. So أكيد لأنه an AI we need to train it على data, and now that we have much more data, it's a little bit more accurate.
Exactly, perfect. So now we can train it because we have the data. And another thing is because also we have what? Okay, so I'll answer it.
Power, actually.
Exactly. So we had the algorithms, the actual algorithms back then, but we couldn't use them because one, they needed a lot of data which we didn't have and which was much more expensive. And also we didn't have the computational power. So we didn't have the actual hardware that would support such training. Now we have both, and this is why AI has come to fruition in the last few years. So let's define some terms together. AI, artificial intelligence, it's any intelligence that's not human. So anything that humans use their intelligence to do, if another creature or a machine does that, that's artificial intelligence. Machine learning are, so it's a subset of AI, and machine learning is the mathematical and statistical equations that are used to achieve intelligence. Deep learning is a subset of machine learning. So deep learning are neural network like architectures. So we build them from the same equations that are used in machine learning, the same mathematical and statistical equations, but we build complex architectures from that. So that's what we call deep learning. And that's what I just explained. So what is machine learning? And let's do a case study on why machine learning is something that we should look at and we should consider. So for example, let's solve this very simple problem. We have a handwritten digit. So here, for example, we have a 9, we have a 3, we have a 7, and we want to build a program that when we give it this image of the handwritten digit, it should give us the actual digit, so label 937. Let's do the traditional approach. We're programmers here. What do we do in programming to solve the problems? So what we do usually is we build a logic in our heads. So if that's the case, then we do this. If that, then that. We do some while loops, for loops, and some combinations of that. But mainly, how can we solve the problem that I did with the traditional programming approach? So let's say we have a 7. We say, okay, if all of those squares are white and all of those squares are black, then it's a 7. But maybe the 7 is rotated a little bit. Maybe it's to the upper left, right, left corner, or upper left corner of the image. Maybe it's a little bit smaller, a little bit larger, and
Manipulate
this is
image.
only one digit. Do that for all of the 10 digits. It becomes an impossible problem to solve with traditional programming. Do you agree?
Yes, but it becomes much easier because right now we have tools where we can manipulate the image, we can turn it around, flip it 180, 90 degrees and all of that. So we know it's a 7. لو كيف ما اجت حتى لو اجت 7 بالقلب, we know that it's
Yes, مظبوط. بس we know it's a 7 لأنه we saw it, we know it's a 7, we know it's rotated. But if I give you a random picture of a 7, okay, and I tell you write a program that recognizes the digit from the drawing. Okay, how would you write such program? with traditional programming we can't do that because إذا بدنا نستعمل if statements. Okay, so if this square is white, this square is white, this square is white, and these are black, then it's a 7. But if the 7 is crooked a little bit, if it's rotated, if it's smaller, uh, our program no longer works. So we need a more general approach. We need an approach that would recognize it and would recognize the feature that makes this digit a 7. So we need something that's a little bit smarter, and this is where machine learning comes into play. So the machine learning approach is we have a much shorter program. So it's like a few mathematical equations, and what it does is we take this algorithm, we let it study the problem and make predictions. The predictions that the program makes are either right or wrong. If the predictions made are almost always right, then the program is good enough to use. If not, then we need to train it more, we need to teach it more. So يعني this is the machine learning approach. And in machine learning, we have three main types. So we have supervised learning, unsupervised learning, and reinforcement learning. Let's explain each one of those. Supervised learning is when we have the question and the answer. So, as an example, the one that I gave you earlier here. So this problem, we have the handwritten digit and we have the label. So we give the program the digit, the hand-drawn digit, and we say that it's a 9. So we have the question and the answer. That's what we call a supervised learning problem. An unsupervised learning problem is when we don't have the answers. So we just need to group or cluster similar data points together. And here, machine learning recognizes the similarity in the data. With reinforcement learning, we have something very interesting. If some of you play chess, the chess bots, they are trained using the reinforcement learning method. They know the rules of the game, okay, and whenever they lose, they get a penalty. Whenever they win, they get a reward. And with millions of games played, they start to recognize the behavior that makes them win and the behavior that makes them lose. So they do more of the behavior that makes them win to get the rewards. So this is reinforcement learning. Some examples of what I just said. So for supervised learning, we have classification for fraud detection. So we classify this is a fraud or this is not a fraud. For example, regression, let's say estimating the price of a house. In reinforcement learning, we have game AI, self-driving vehicles, real-time decision making. And for unsupervised learning, we have clustering where we group similar data points together, or recommendation systems where we group similar customers together and that's how we do the targeted marketing. And so let's watch together this fun video of how supervised learning works. So I have here an AI. Okay, watch how its brain grows. I show it a dinosaur. I tell it it's a dinosaur, and it learns from that. So I'm teaching it right now. I was teaching it, and now I disappeared, and it suddenly sees a dinosaur. So it should make the decision, and it guesses that it's a dinosaur from what I already taught it. So here, I'm teaching it. This is a dinosaur, and then the AI. When I disappear, the AI knows that it's a dinosaur. I gave it the question and the answer, and that's what we call supervised learning. As I said, we have two types of supervised learning: classification and regression. Classification is when we have a set of actual predictions. So let's say this person uh, has uh, has diabetes, yes or no. So we have two outputs, two possible outputs. That's a classification. We can have also regression with when we predict continuous values. So let's say I'm predicting the price of a house. The price of a house, let's say, is it's $200,000. It can be $201,000. So it's a continuous value that we're predicting, and that's what we call regression. For unsupervised learning, here it's grouping similar data points together. So the circles are together, the spirals are together. Here the arrows are together. This round thing with a stick, those are together, and the parentheses with the stick are also grouped together. For reinforcement learning, we all played the game Pac-Man. So Pac-Man increases its score when it eats the white stuff, and it loses if the ghost eats it. So here there is a reward and a penalty. When it gets eaten, it gets a penalty, and when it eats the white stuff, it gets the reward. And it should do it as fast as possible also. Now, let's move on to deep learning. So we finished with the machine learning part. Now, what did I say about deep learning? So deep learning is a subset of machine learning, but it's the same machine learning, let's say, equations that are used in a neural network architecture. So here, this architecture, what we call the neural network. Every cell in here is what it contains is an activation function. This function is actually a mathematical or statistical equation that has parameters. So during the training process, those parameters are tuned, and then when we want to use this neural network, we give it the data in the input layer, it processes it in the hidden layers, and then it gives us an output in the output layer. Now, let's take our previous example of case study and let's analyze it. Let's analyze how we can solve it using deep learning. I gave my neural network the input image. It has 4 hidden layers and the final output layer. Okay, as you can see, I gave it a 4 and it correctly predicted a 4. So all of the 10, all of the, let's say, 9 cells that are wrong, they are turned off, they are black. And the one cell that is correct, the 4, is bright, it's lit up. So the neural network predicted that what it saw in the input layer is actually a 4. How did it do that? So what it did is in each of the hidden layers, in each one of them, our neural network, it predicts, it analyzes the image, searching for some features in it. And if a combination of features is present in the image, then it gives the output. So here it recognized the features that are in the number 4, and that's why it gave us a 4 in the output. So that's how our neural network recognized that what's in the input is actually a 4. And how did our neural network know what features to look for? It knew what features to look for when we did the model training. So during this training process, what we do is that we give it an input and our neural network predicts an output. We compare this predicted output with the actual result. So we actually have a 4 and our neural network predicted that we have a 5, for example. So here we have 2 different outputs. This the difference between these outputs is calculated using what we call the loss function. So we compare the true output and the predicted output. We get the loss score by the loss function, and if the loss score is high, then our model predicts wrong values. If the loss score is low, then our model predicts the correct values. And the training process aims to have the lowest loss score possible. But we were using machine learning for a long time, so it's been like more than 20 years that we're using machine learning. But why in the last few years did neural networks overtake machine learning in performance, and why did neural network right now they are delivering great results that we couldn't dream about a few years earlier. So can you give me an answer? Okay, so I'll give you the answer. It's because neural networks need more data and better hardware to train, and that's why now we have a lot more data and we have more capable hardware. That's why we are now able to train neural networks and to achieve higher accuracy and higher and better predictions than the traditional learning approaches. Okay, so I was talking about AI, machine learning, and deep learning, but I haven't mentioned data science yet. So, what is data science? As you can see here, data science is a tool that we use in everything regarding AI. So, we use it in artificial intelligence, machine learning, and deep learning. What are those tools? We're going to talk about them, but first let's talk about the data science life cycle. So in this life cycle, we have a business problem, and someone tells us, okay, we need a model, we need something that predicts the handwritten digits. So this is the problem that we have. What we need to do is understand the problem, go get the data using data mining, clean the data. So we have data that is collected from multiple sources. We want to clean it and then explore it, know what the data has, do feature engineering to make the data usable for the AI model. And then in the predictive modeling part, this is actually where we go get an AI algorithm, we train it using the data, and then after that we evaluate this model, we get the results from it, we visualize the results, and uh, this is the data lifecycle. Okay, I talked about data processing. What is data processing? So we get data that is dirty, so it contains wrong, let's say wrong or incorrect or missing rows, for example. So that needs cleaning. And then if we have data collected from multiple sources, we do data integration. Data transformation is used to have similar ratios between the data, but with smaller numbers. This is computationally better than having large numbers. And for data reduction, we just compress, for example, the data set until it has the same amount of information, but with less data. So it's also computationally lighter for the AI model to train. And we do the exploratory data analysis with plots, graph, and hypothesis testing using statistics to know what data we actually have. After that, we do the feature extraction. So, for example, if we have the birth date, we can convert that feature into the age. The age is more useful than having the birthday, for example. So this is what we call feature extraction. Now that we have the data, we feed it into the machine learning algorithm. We train it. So we have training data and the output labels. We feed those into the algorithm, and we now have a trained model. The model is now ready to do prediction. So we give it a row of data. We give it data that it has never seen before, and then it gives us the predicted output. Some of the challenges of AI are gender and racial bias found in, let's say, Amazon facial recognition model was having a gender bias, so it became racist, for example. This is something that big companies they cannot release an AI model that's racist, for example, so it hurts their image. That's an example of the challenges of AI nowadays. And also, the data is not always free. The data is very expensive, so we may need more data, and this costs us money. The generalization and scalability of the machine learning model beyond the data that it has been trained on, this is also something that should be taken care of. Okay, so let's take a 2-minute break, and then we'll move on to the actual notebook where we're gonna train an AI model. If you have any question, feel free to unmute yourselves and ask them. So I'm gonna share my screen to the notebook that we're gonna work on. We have this Jupyter notebook. If someone wants to code with me, I'm gonna send you the. Okay, if someone wants to code with me, I'm gonna send you a link to a GitHub repo, and you can find the notebook there. Just a second. Okay, so you can go to. Okay, so if anyone wants to code with me, you can download this Python notebook and run it on Google Colab. If you need any help, please unmute yourselves and ask me about it. But okay, I'm gonna start with the notebook. Our data, we have a data set, and we want to predict the insurance charges for the people involved. So what we have some information about these people. We have their age, their sex, their BMI, how many children they have, if they smoke or not, the region that they live in, and the actual insurance charges that we want to predict. So what do you think this is? Is this supervised learning, unsupervised learning, or reinforcement learning? So we're predicting the insurance charges, and this is the data that we have. What do you think this problem is? Okay, so this is a supervised learning problem because we have the input and the output. Okay, so let's go together. We're gonna take a look at the data, but first we need to hook our notebook to the Google Drive to have access to the data. Okay, so what I'm gonna do right now is I'm gonna get the data by cloning the GitHub repo right here. So here we have the data. Okay, so let's go to this directory to fetch the data from there. Here we can see the insurance.csv. And this is the path to it. So let's copy it. And to load it, we use the read CSV function in pandas library. Okay, so this is our data set. Let's print the first row, 10 rows of it. So this is the data that we have. Okay, now we're gonna check how many rows and how many columns do we have using shape. So shape 0 shows us how many rows, and shape 1 shows us how many columns. We have 1,338 rows and 7 columns. Here, using data info and describe, this shows us some information about our data set. And now we want to plot a histogram. So to plot a histogram in Python, we use dot plot, and what kind of plot do we want to show? We want to show a histogram, so we say hist, and this is what we get. If we want to only see the people that are smoking, so we want to differentiate between them, we need to select them from the data. So we say uh, data dot smoker equals yes, and here data dot smoker equals no. So now we have 274 smokers and 1,000 non-smokers. Uh, if you want to draw the charges of the people that smoke, we say histogram smoker charges, and here the same thing. Histogram non-smokers charges. Let's check. Okay, so as you can see, for the people that smoke, they have higher charges than the people that don't smoke. So let's check what about the age. So does the age affect the charges? Let's see. Data age, and here for the age distribution, it's actually not that different. We have all of the ages, and let's see the charges. So let's draw a scatter plot. Data age for the x-axis and For the y-axis, we're gonna have the charges, so data charges, and as we saw, we have similar numbers for every age group, so we don't have to do anything. The scatter plot is gonna show us a fair amount, for let's say, and as you can see, we have a line that goes upwards. So as the person grows in age, their insurance charge also increases. And for the people who smoke, they are the red dots, and they are actually ranked higher. So they have higher charges than the people who don't smoke in all of the ages. So that's concerning for the smokers. Okay, now let's move to the body mass index. So we want to create this feature, the body mass index, the BMI, which is the weight divided by the height squared. And here we have a graph that shows us what BMI is: underweight, healthy, overweight, obese, and extremely obese. So let's draw this the histogram of the BMI. So here you can see it's a normal distribution. So most people are in the healthy side, and we have a little bit of underweight and a little bit of obese people. So we want to get the data of only the obese people, only the overweight people, and the healthy people. So the obese people, they have a BMI that is higher or equal than 30. So that's what we're gonna say from the data. Okay, we're gonna get people that have their BMI actually higher or equal to 30. The overweight people, they are less than 30, or and also these people are more than 25 or equal to 25. Healthy people, they have a BMI higher than 19 and less than 25. So here we have 700 obese people, around 400 overweight, and around 200 healthy individuals. So let's plot their charges. So a histogram for the obese charges, and we're gonna have the color red for them. Let's do the same thing for the overweight and healthy. So for the overweight people, we're gonna have the color, let's say yellow, and for the healthy people, we're gonna have the color green. Just a second. Oh, here it's color. Okay, so the obese people, they have the highest charges, then the yellow, so the overweight, and the least charges are for the people in green. let's see if we have any null values. Okay, so we have 3 null values in this column. So I think we should drop these 3 columns. We should remove them from the data set. So what we say is drop NA, so drop null values. And now we have 0 null values in our data. Okay, now also the region, it has no actual value for us, so it doesn't mean anything. So let's also drop this column. Place equals true. Okay, now we don't have the region column anymore. But as you can see here, for sex, we have female, male, female, male. We want to replace the male by a 0 and the female by a 1 to have all numerical values. And we're going to do the same thing for the smokers as well. So let's do it for the sex. So here, data, sex, okay, dot apply, lambda x. So here it's a lambda function, gender of x. Okay, now we have zeros and ones. Let's do the same thing for the smokers. So and now we have also ones and zeros. Uh, okay, so now we're gonna do the data normalization. So we want to have the data points that are close to 0, and that's why we need the maximum values for each column, and these are the maximum values for each column. Now we want to divide all of the values with the maximum value, so we use divide and data max. Okay, now we divided those values. We have values between 0 and 1. Okay, here we want to create a training data set and a testing data set. So we have the actual data set in X and Y. And let's say we want the test size to be 20% of our values. So here 0.2 is 20%. If you're coding alongside and you want to get the same values as me, you want to use this random state, so we get the same data sets. And let's say here random state equals 42. You want to have the same number as me to get the same data set and thus the same values that I'm gonna get later on. So here for this problem, we're predicting the charges, which are continuous values. So we need a regression model. I'm going to use the linear regression model. So this is how I define it. And I'm going to train it to the data using the fit method. So here, fit, x train, and y train. Okay. I should use a small x. Okay, now, as you can see, my model is trained. Let's see the score of this model. So here, score on the test set. So x underscore test, y underscore test. Okay, so we have 80% score. So let me do a percentage. Multiply this by 100. Okay, let's have 2 floating points. Okay, so we have 80% accuracy on our data, and let's see which column or which factor contributed the most to the prediction of the model. So here we use the coefficient, and the smoking is the thing that contributes most to the actual insurance charges, as long along with the BMI and the age. So those are the three highest contributors to the insurance charges decreasing or increasing. And there you have it. This is our workshop. Thank you for watching, and thanks for your attention. If you have any question, please feel free to ask them.
Thank you, Hadi, for your time. Thank you so much. Please feel free to ask your questions.
You're welcome. You're welcome. Okay. Thank you, everyone. You're welcome, Lean. Anytime.
Thank you. Bye-bye, everyone.